Hello, in this video I will be showing you a DIY homemade soldering iron powering module, and I will be giving you some details about this project, and we will be looking at the schematic diagram as well as the Arduino code for running this project. So let's first see how this project is working. As you can see here, I'm using a 24 volts 5 ampere adapter to run this module, and that 24 volts is being stepped down for the Arduino and rest of the sub modules of this project. The 24 volts is also directly available for this soldering iron, as we know that these soldering irons, they require between 19 to 24 volts, and 24 volts is the ideal voltage for these soldering iron to operate. So first of all, here we can see that we can see here there are two display. First is the actual temperature, which is showing cool right now, and the second one shows the preset temperature that is right now in the off state. First of all, I would also like to thank the tech builder who has also presented his own video on YouTube, and I actually learned a lot from that video. There were some additional tips and tricks that I wanted to give you if you are planning to work on this project that I had faced during the development of this, right? So as we can see here, we have a potentiometer right here, and we can increase the temperature by turning the knob. And as you can see, if I'm changing the temperature, so after some time the thermistor that is available within this iron senses the increase in temperature, and we can see this LEDs glowing in a constant state until the temperature rises to the desired temperature, right? So when both the actual and preset reaches at an equal state, or you can say the actual temperature reaches the preset temperature, then the PWM mode will start there, so that we can have that continuous pulsating output to this soldering iron, and it will also prevent it from overheating. So right now, if I just show you, this soldering iron is almost ready to work with. You can see it's pretty hot right now, right? So now if we just bring the temperature down to like 300 degrees Celsius, it will take some time to bring the temperature down, and during that period, as you can see here, the LED is not glowing, it is turned off. This is due to because the PWM mode is now in off state, so that the iron can just step down its temperature, and when the temperature of the iron reaches to this 300 degree or near to this 300 degree, which is the preset temperature, then again the PWM mode will start there, and the constant mode will only be turned on when there is a big difference between the preset and the actual temperature, right? So now we can see that the actual temperature is coming close to this preset temperature, and here the PWM mode kicks in again, right? Here we can see at 300 degree this iron is still in good state, and we can still solder using this iron. But as you can see, the intensity is reduced, right? So you can see it is melting the wire, but not in the way we usually require, right? And one good thing about this program is that is the code is you can easily modify the code as per your requirements. And uh, when we reduce the temperature to the minimum, that is the preset temperature to minimum, it will show you the off state, which is written right here. And also you can see that the actual temperature now is uh, again going or reducing, right? So these the actual and the preset, they are all programmable within the code, and I will show you how we can set that temperature. And this is where you have to be careful, and you have to play with your new iron, right? Because this is where I was stuck for like 2 days, because these soldering irons they come with different thermistors, and since most of these thermistors they have unknown values, so we have to first check the minimum and the maximum thermistor value for minimum and maximum temperature, so that we can put that value. uh, for that we have to go through a small code, Arduino code. I will show you uh, right after this explanation. So here I would like to open this display so that we can see what's below this display, and how the components are placed on this prototype board. But you can actually redesign this whole circuit on a PCB. And I would suggest you that first you should also work with a prototype board instead of directly going towards the PCB designs, because most of the time we have to just change some of the components or alter the schematic due to various reasons, right? So I have changed the schematic that was previously provided by the tech builder. I have added some of the components, I have changed some of the pin configurations as per my desire. So uh, yeah, you have to first go for the prototype version instead of directly going towards the PCB, right? So let's first disassemble this board and see how the components are placed, right? So here you can see that I am going to just pull up this LCD display, and first we can see that this is a simple 16 cross 2 LCD with the converter, so that we can have this serial output from this LCD. So you can add either the blue or the green LCD as per your need, and this is also an optional component. If you don't want to add this converter, you can just simply directly connect the pins of this LCD with the Arduino, uh, which is a simple standard procedure, which is also readily available online. So this is the module, and as you might know, this variable which is being used to vary the light intensity of this display. So the good thing about this the module is that you don't need to add a separate potentiometer for the intensity calibration. That is why I have chosen this. Also, as you can see, this makes things pretty compact and easy connections. Just you have to first solder these, and rest you have to just play with the two pins, because the rest two are the power pins, right? So that's all about this display. And now we are going to bring up this power board, which is the actual uh, agenda of this video. As you can see here, this is my designed prototype, and here we have the Arduino Nano, and we have the DC-DC MP1584 step down converter, and we have the up amp LM358, and a simple driver for either you can say giving the pulses towards this iron, or giving the constant voltage mode, right? So the first option that you can have instead of this module is you can simply use the IRL Z44 MOSFET, but since I don't have that with me, so I just connected this module. And also this is very easy to just connect with your Arduino, and place the wires here, and you can simply test your soldering iron, right? So these two MOSFETs, that is D let me zoom in for you, that is the D4184. They are pretty powerful MOSFETs. They have ultra fast switching capability, and yeah, this is more than enough for this project. They don't heat up. You don't have to place any kind of a heatsink on this these MOSFETs. So I'll definitely recommend, if you can if you have this, you can simply use it. Otherwise, if you have the IRL Z44, then that would be a suitable replacement for this, because most of the MOSFETs are not going to work well with this project, right? Okay, so I have used simple power connectors, and this is a 3-pin connector for the potentiometer that I showed you previously. This is the potentiometer, and this is actually a 10K potentiometer. I will give you the details of each and every component in the schematic diagram, so don't worry. All right. Also, we have this connector for the soldering iron, and as you can see here, I have placed a reverse biased 1N4007 diode, which is for the which is attached with the heating element, because we know that the inductive load can give you high voltage spikes that might damage your component, right? So don't forget to add this diode. As I mentioned, this is a simple prototype version, but later these all components will be added on the actual PCB board, right? So this is the front portion of this board, and there are some resistors. I will explain it to you on the schematic diagram as well. Alright, so now let's check out the backside of this board, and as you can see here, I have tried to use minimum number of jumper wires on this PCB, so that it should look neat, and I'm still pretty sure that this is not as neat as it should be, but still it is doing the job, right? So you can also try this type of soldering, or you can actually buy the other version of a prototype board that have the uh, short lines in vertical direction, right? So that would help you a lot with this uh, connection. It will make it the job much easier. Also I have this 4 uh, pin header connector right here, which is used to connect the this simple 16 cross 2 LCD, right? So all you need to do is place it on it and tight these screws. So this is all about this board, and let's talk now about this op amp, which is the important thing to be discussed, because this is where you might just get stuck and you have to recalibrate for your soldering iron, right? Actually what happens is when you are going to connect your soldering iron with the same circuit, you might have to change the 3 resistors that are connected here. Let me grab my screwdriver here, and this is the uh, first resistor, this is the second resistor, and this is the third resistor, right? So you have to you might have to change these resistors, and I have added an additional capacitor over here and a capacitor over here to remove any kind of noise which is highly not acceptable at the input of this op amp, because since we have to set this op amp for high gain, and we have to be very careful that a simple small noise at the input of this op amp will produce a large output voltage spike, which in turn will decalibrate your settings for the Arduino. So yes, we have to be very careful at the input of this op amp, right? So these 2 resistors are connected at the input and the output of this op amp, while this resistor is connected in parallel, sorry, in the series with this thermistor of this soldering iron, because we have to create a voltage divider circuit, so that that will be the right method to just sense the temperature or the resistance change of this thermistor, right? So let me take you towards the circuit diagram so that I can explain you in a better way, right? Alright, so this is the actual schematic that was shared by Tech Builder, and here we can see that the iron temperature sensor pins are connected to the input of this op amp, and the heater element is connected to some kind of a driver, uh, which in this case is the IRLZ44 MOSFET, while I have connected the D4184 module, right? So you can choose either of these 2 options, which is easily available for you. So you can see for the LM358 we have 3 resistors, that is the 470 ohms, 2.7 kilo ohms, and the 3.3 kilo ohms resistor, and the resistor which is connected to the non-inverting input, which is the 2.7 kilo ohms, and the 3.3 kilo ohm resistor, which is the feedback resistor. These 2 resistors play the key role for providing the actual gain to the input, which is the non-inverting pin, right? initially what you are going to do is connecting your soldering iron at the this point and keeping this 470 ohm resistor as it is. You're going to use a multimeter and see the voltages for the minimum and the maximum temperature of your soldering iron at this point as well as at this point. All right. So if the voltage, especially at this point, is above 0.5 volts and under 4.8 volts, then you have the right resistors, that is the 2.7 and the 3.3k is right for you, right? But in my case I have to change these two resistors because the output uh, of this op amp was still in millivolts, right? So since that value is not acceptable for the Arduino, so what I have to do is I have to change these two resistors. I used the online calculator, and you can also use some kind of AI tool uh, to make the estimation for the value of these two resistors. And after that, when you are going to see a good voltage at the output of this op amp, then it will be ready to be connected with your Arduino. This is one of the key change in this circuit. The second thing that I showed you was the capacitor, the ceramic capacitor, which I connected at the pin 3, which is the non-inverting input, and the pin 4, right? This was connected to ensure that if there are any kind of high frequency noise at this point, then it must be grounded. Otherwise, since we have a high gain at the input, the high gain set for the LM358, so a small noise can change the actual results, right? So we have to be very careful. One important point I want to add for this circuit is that you have to connect the 5 volts or the input voltages of the LM358, that is the VCC for the LM358, and the VCC or the pin 1 and pin 3 of this potentiometer to the Arduino output, 5 volt output, right? And don't connect these uh, potential requirement to the DC connector output. Otherwise you are going to face difficulties while calibrating this op amp. I have faced it, that is why I'm suggesting you not to do that, right? Most of these temperature sensors, they have the polarity sensitivity, right? If you are going to connect in the right direction, so you will see a positive or the rising temperature and as well as the voltage at this point, right? While if you are going to connect it in the reverse direction, so definitely with the increase of temperature, the voltage will go down. So you have to keep this thing in mind. Also you have to ensure that the voltage of the output voltage at pin 1 of LM358 should not go above 4.8 volts, because after that the voltage will be clipped off, right? Obviously, because the Arduino cannot read values above 5 volts, so we have to keep it below 4.6 4.5 volts and keep a safe window or margin so that the voltage might not go above the uh, capacity of the Arduino reading capacity, right? Next, you can see we have this 10k potentiometer over here, which is being used to set the temperature the temperature of your soldering iron. Next we have this LED. This is just for the indication to show you either your soldering iron in constant uh, power up mode or in the PWM mode. Alright, so this is the code that I was talking about. um, as I mentioned earlier, that you can change these four values for setting the actual temperature, sorry, the set temperature for your soldering iron. But I have also changed two other values, that is the average counts, which is the number of samples that this Arduino takes before changing the actual temperature of your display, as well as the LCD intervals, right? It was set to 80, as I changed it to 200, and the average count is also being changed to 10 instead of 5. The reason is because while I was keeping the original values, I noticed that the display was changing very quickly, and I just wanted to be have the smooth change of values for my project. So a little delay, since it is in milliseconds, is acceptable, right? And the rest of the code is as it is. This is a simple code that you have to first burn into your Arduino, and then you are going to just go to the serial monitor, and it will automatically start going to display you the uh, output of your soldering iron temperature sensor values, right? So you are going to note the minimum temperature value and the maximum temperature value. From that, what we are going to do, we are going to place those values at these points, right? That is the minimum ADC and the maximum ADC. So the code have very simple separate parts. As you can see here, this is for the display, this is for the power up operation of the soldering iron, and here some other values or the variables for setting the sensor data or mapping it. And finally we have some variables right at the start of this code. So that's all for the project. And finally I'm going to connect the LCD back so that we can see if this project is again working, right? All right, so all the things are now connected back, and finally now we are going to see if it runs again. And yes, we are going to change the temperature. I have set it to maximum, and the sensor takes some time to sense the change in temperature, and then we are going to see it right here, right? So as you can see here, this is a very smooth transition of temperature from its lowest value to the highest value, right? And as I mentioned, just change the ADC values as per your the output of your soldering iron to have the exact minimum and maximum temperature of your need. I have tested my soldering iron that near 420 degrees centigrade. It gives me good output from my iron, but you can change it as per your soldering iron. So now you can see we have this PWM mode, and finally it is in ready state. So I hope you have enjoyed this tutorial, and if you have any queries, do just put it in the comment section, and I'll be happy to answer you. All right, so that's all for today. Take care, have fun, bye bye.